Welcome to our deep dive into mastering the OAuth 2.0 protocol, a crucial standard for modern security and authorization. We'll start by setting the stage and understanding the foundational concepts behind OAuth 2.0. OAuth 2.0 is an authorization framework that enables applications to obtain limited access to user accounts on an HTTP service, like Facebook or Google. It's needed to provide delegated authorization without sharing credentials. The core concept of OAuth is delegated authorization. This means a user can grant a third-party application permission to access their data on another service without exposing their password. To understand the flow, we must first recognize the four core roles involved in the OAuth 2.0 process. The resource owner is the user. The client is the application requesting access. The authorization server verifies the owner's identity and issues access tokens. The fourth role is the resource server, which hosts the protected user resources, like the user's profile data or photos. OAuth 2.0 defines several grant types, each optimized for a specific use case, that define how an application obtains an access token. The authorization code grant is the most commonly used and secure method, typically employed by server-side applications. The client credentials grant is used for machine-to-machine authorization, where the client is acting on its own behalf, not a user's. Let's walk through the steps of the most common grant type, the authorization code flow. First, the client directs the user to the authorization server, where the user logs in and grants permission. The server then redirects the user back to the client with a temporary authorization code. Next, the client securely sends the authorization code and its own credentials to the authorization server to exchange it for a valuable access token. With the access token, the client can now make requests to the resource server to access the protected user data, as permitted by the user. Access tokens are the core credentials, but what exactly defines what they can access? That's where scopes come in. Access tokens are usually opaque strings, but they typically represent authorization credentials and are used to verify permission to access resources. Scopes define the specific permissions granted, limiting the client's access. Refresh tokens allow a client to obtain a new access token without re-involving the user. Security is paramount. Let's look at a key best practice for public clients, like mobile apps. PKCE, or Proof Key for Code Exchange, is a crucial security measure used primarily for public clients to mitigate the interception of the authorization code. Ensure that access tokens and refresh tokens are stored securely using mechanisms like encrypted storage or secure HTTP-only cookies to prevent client-side attacks. You now have a solid understanding of OAuth 2.0 roles, grants, flow, and key security practices. The next step is to begin implementation.